Hey there, and welcome back to another episode of the Offset Podcast. And this week, we're taking a look at essential IT terms and workflows for post professionals. Stay tuned.
This podcast is sponsored by Flanders Scientific, leaders in color-accurate display solutions for professional video. Whether you're a colorist, an editor, a DIT, or a broadcast engineer, Flanders Scientific has a professional display solution to meet your needs. Learn more at flandersscientific.com.
All right, everybody, welcome back to another episode of the Offset Podcast. I am Robbie Carmen, and with me, as always, is my co-host, Joey Dana. Joey, how are you doing, man?
Hey, everyone.
Joey, continuing on our trend of episodes that are squarely in your wheelhouse, this one actually came up after talking to some friends on a Discord group I'm a member of, and I have somehow, which is very scary to me, that I have defaulted to becoming an IT resource for a lot of people when I always think of you as my IT resource. So it kind of got my wheels spinning on an episode of there's a lot of things with just IT, information technology, computer stuff, tech, whatever terms you want to throw on it, that I think a lot of people in creative fields are just like, oh, I don't know about that, or I have a guy for that, or they know enough to be a little dangerous, but not like fully versed in it. And to be clear, this is a blind spot for a lot of people, but like there are professionals for a reason, right? And we're not advocating, like, if you're outside of your comfort range with anything, of course, listen to this episode. Maybe it will help. But also, there are IT professionals and engineers for a reason. So I don't want anybody to feel like they have to do this stuff. They can get over their head. You can always call for help, right?
But also, it's one of those things like, you should know a lot of these terms and concepts because let's say you're at a massive Fortune 500 company with a huge IT department. When you interface with them, if you understand the world a little bit, you'll be able to more effectively communicate.
Yeah, and for the sole proprietor, the small company, a lot of this stuff is, it's easier than it's ever been. It's standardization, consistency across various companies, platforms, etc. If you kind of get some of the big, larger concepts, then you can kind of parlay that into your specific thing. So again, the goal of this episode is not meant to be comprehensive and be like everything. And if you're already an IT professional, this episode is squarely not for you, right? We're not going to get into the thick of it. We're not going to once talk about getting into the command line and doing things there, or SSHing into something or whatever. That is a different world squarely. But what I wanted to kind of start at, Joey, is the basic building blocks of an IT infrastructure, because I see this all the time. You're talking to somebody, right? And you say something and I'm like, oh, okay, well, is that plugged into your switch? And they go, well, yeah, it's plugged into the router. I'm like, well, okay, well, those are two different things. Could be the same box, but two different concepts. Or, they'll say things like, oh, well, yeah, it comes in from the wall into my router, but I don't know what the wall means. Like, okay, is there a cable modem attached? Like those kind of basic things. So let's start at kind of the top tier of that, right? Presumably, you're going to sign up for, whether it's at home, the office, wherever, you're going to sign up for some sort of internet service. Let's just call that group your ISP, the person that is providing you the pipe to the outside interwebs. And oftentimes when that comes in, it's going to come in a couple different ways. One, it could come in through a modem, and people have had modems for years, right? These are common with coax type connections, right? They can be common with some fiber providers. But there are also, the other thing that you'll see oftentimes is what we refer to as an ONT, right? Which is kind of, if you've ever had a fiber service like Verizon Fios or something like that, you might have a box in your garage or on the back of your house or something like that, that essentially operates as that interface between you and the ISP.
Yeah. So basically, most internet service doesn't come to your premises as the same type of networking that you would just plug into a computer, right? So whether it be a modem, which is, modulator, demodulator, it's the legacy terminology for what we used to use analog phone lines to convert networking signals. These days, it's used for digital cable, coax, like you mentioned. ONT is the fiber equivalent of that, an optical network terminal. It takes the optical cable connection from your fiber provider, does all the conversions needed to convert it to the kind of base level format for networking that almost all modern computers use, which is Ethernet. So that's your modem or whatever terminal to your service provider. From there, that will go into something called a router. And what a router does is it takes one network, converts and moves traffic from that network to and from another network. Now, in most residential applications, a lot of times the modem and the router, and even we'll talk about switches a little bit later, but also a switch is consolidated into the same piece of equipment. But it's actually two different kind of things inside of that equipment. We're going to take our network from our ISP, make it into Ethernet, but then that Ethernet just gives you one network address in most cases on the internet that you can now talk to other machines on the internet from. But that's a public address that you don't want to actually be connecting your computer to. So what your router will do is create a internal network of private IP addresses that all of your computers in your network can exist on. And when they talk out to the internet, the router will migrate the traffic to and from wherever you're going on the internet to your internal addresses. The next major building block is a switch. What a switch does is, let's say you have 10 computers hooked up. If you have one computer connected to another computer with Ethernet, they can talk A to B, right? But if you have A, B, C, D, E, you need to be able to talk from any point to any other point. Right. So they all go into a central switch. It's what it's called. It's called a switch. And that switch will broker all the connections from all the connected machines. The last building block is the individual machines. And you may hear the term NIC, network interface card. That's important because your computer might have more than one. Your laptop might have an Ethernet port and it might have a wireless adapter. Your workstation might have 2 or 3 Ethernet connections. And when you get into more advanced things like internet here, storage here, that matters.
Yeah, and we'll talk about some of those multi-connection things in just a moment. That's a great overview, and I just want to add a few additional terms here. So you mentioned the outside internet, the ISP coming in, and then your internal network. And these have words or acronyms that you might see. You might see it advertised as your WAN, right, and your LAN. Right, where WAN is going to be your wide area network. That's the internet coming in. That's the pipe coming in from your ISP, which is, as you said, a router then translates that into a LAN, your local area network, right? So this is an interesting thing because I think a lot of people get a little confused about how this works, and when it comes to what an IP is. Now, I think everybody on some level knows what an IP is. We don't have to be that pedantic about it, right? Like, I think people go, oh, an IP is an address that tells a computer where something is located. It could be out there in the world. It could be something local to you as well, right? But I think a little bit of confusion happens with the following. You have a WAN IP from your ISP, right? They assign to, when you sign up, they go, oh, there's Robbie's house. I'm going to give that house an IP. Now, that IP, most of the time, is not always the same. The internet service provider might say, hey, every 2 weeks or 3 weeks or a month or whatever, or the next power outage or whatever, we'll reassign that, right? But your incoming network has an IP. Let's just call that the public IP, right? That is the world knows, hey, when something's going to Robbie's house or Joey's house or whatever, this is the IP that I'm sending it to. That public IP is different, right, from your internal IPs and your internal networks. And I think that's a big
And to be clear, just theoretically, you could skip the router, plug your computer right into that single public IP, and have your workstation be directly on the internet. And it would technically work. It's a horrible idea, but just so you can understand kind of how this architecture is, in most setups, your router will occupy that public IP address.
Right. So what that router is doing is translating, okay, I'm, 76.234 or whatever publicly, but internally I want my machines to be maybe on 192 IP addresses or 10 IP addresses. Those ranges of IPs, which there's some standards to it, right? You can go on Wikipedia.
10, 192, and I think 172 are dedicated internal network ranges.
Right,
so they will never, there cannot be an internet address on those addresses.
And IPs fall into two major classifications, IPv4 and IPv6, right? And 6 is a newer standard. It basically just allows for larger blocks of addresses. For a long time, the world has been worried about running out of IPs with the previous version, with version 4. 6 is still, even to this day, not nearly as widely used as 4. We haven't quite run out yet, but just understand that if you will see that sometimes, especially when it comes
to our
to
purposes, when we talk about the internal network, we're never going to be running IPv6. There's no reason. Right,
exactly. There's no reason.
If your ISP is running IPv6, the router is going to handle all that translation.
All right, so we understand how that translation happens on the router. We understand the building blocks, right? A switch, router, NICs. And just to be clear, you said this, but I just want to reiterate this. A lot of consumer devices have those concepts combined together. Like you might have a WAN port, that's where your internet coming into your house or your office comes in. You plug that into your WAN port. But on that same device, you might have a bunch of Ethernet ports that are meant for your local area network. And that's where it's sort of operating as a switch in that same box, right? So
yeah, essentially, like if you just buy Fios, you get a box that has the one WAN port. There's a router inside that box. There's a switch inside that box. And there's also a wireless base station inside that box. Right. All of those are together in one consumer appliance.
So you can break that out, of course, which we'll talk about more in a second. All right. So now that we got that clear, let's just briefly talk about that local area network thing a little bit more, right? So if we understand that there's external and internal IPs, we can create internal networks. Now, most people, a lot of places you go to, just have a single internal network, right? And on most systems and most routers, that's going to default to just probably a 192 kind of pattern of addresses, right? When that router creates that 192 address or whatever, most routers are set up by default to do something called DHCP. What does DHCP stand for, Joey?
The Dynamic Host Configuration Protocol. Essentially what that means is you plug a computer into the network, and by plug into the network, that could be connecting to it via Wi-Fi as well. That's the same thing as plugging into the network, right? You connect to the network hardware-wise, and then your computer puts out a broadcast packet that says, "Hey, I'm here. What's going on? How do I talk to you?"
Right.
Then the DHCP server, which in almost all cases is also hosted on the router, will respond to that, say, "Hey, okay, your address is this. My address for the router is this. The address for your name server, so you can do lookups, like when you say google.com, something needs to associate google.com with an actual IP address. So the server that does that is listed in your DHCP entry." Essentially, what will happen is when you have that computer plugged in, if the computer is set up to automatically configure, it'll ask the DHCP server, which is sitting on the router in most cases, what's everything I need to know to connect to this network? And the router will say, it's this. And it will keep track of who has what IP address, so it doesn't give the same address to two different machines, because that would end up bad.
And as you said, it's dynamic. And so that's a really important part about this, right? Is that in a DHCP setup, now that we've translated the network to local, now we plugged in a computer and the router goes, "Hey, this is your IP address." That IP address is dynamic. Turn your computer off, turn it back on. Chances are, if something, other activity was going on in the network, it's going to get a new address. You can actually renew this. You probably have seen this in various places on your Mac or your PC where it's like renew DHCP lease rather. That's what it's doing. It's going, hey, router, give me a new address. This one's not working for me anymore. And it will put it out. So DHCP is great for simplicity, right? Plug something in, it gets an address, it knows all the information about how to route things. But for predictability, reliability, always knowing where something is on the network, it can be a little challenging, right? If you always want your computer to be at the same IP, DHCP can be a little problematic for that. So we can also run what's called a static IP, right? So a static IP is going to say, hey, you know what? I'm going to give this device, and there's different ways to set up based on the unique MAC address of that device or other protocols. Say every time I see this device, I'm going to give it this same IP, right? So for example, if you always want your main Resolve workstation to be, certain IP, or a converter or something that you have in a rack mount be the same IP, you can set static addresses for those devices as well.
And there's two ways to do that. Like you mentioned, you can do that. Most DHCP servers have an option to do that. So you don't need to, on the client end, on the computer end, actually go in and manually type everything in. That's kind of my preferred way to do it. It's really a newer way to do it. That wasn't, historically, most people would set up.
You would set it on the computer.
I've got a NAS, I've got a server, I've got a client. I'm going to manually type in those addresses, which is still a perfectly valid way to do it. But for a lot of things, the modern router DHCP server combo, and I think we'll talk about this next when we get into kind of an ecosystem of network products where you have centralized management. It's really easy to do it all from one place.
Yeah, totally. So once we're working static or DHCP, doesn't really matter depending on your needs, right? You have a local address. And as we said, those blocks like 192, 172, 10.0, whatever, those are different IP ranges. It introduces this idea that's, I think, a little foreign and complicated for some people to get their heads around, but hopefully we can explain this pretty easily. The idea of having multiple networks within your network, right? And you're like thinking to yourself, what do you mean multiple networks, right? I'll give you just a breakdown of my house and the reason that I have multiple networks. So at home, I have work stuff, right? I have work computers, right? I have monitors, I have, a whole bunch of things that need IP that I would say are work related items. Then I have a whole bunch of things in the house that I would say are part of the generic term, the Internet of Things, the IoT, right? I'm thinking of smart switches, cameras, doorbell, whatever, right? I don't really necessarily want those things to know about each other, right? I don't want some, potential malware on a cheap little camera I bought on Amazon necessarily knowing about my Mac Studio that I'm making money on using Resolve, right? And then I have the rest of my family who is, on iPads, phones, laptops doing. I certainly don't want some, bad actor on one of those devices all of a sudden knowing about my Resolve computer and potentially doing something bad, right? So it brings up this idea of sort of network segmentation. And most modern routers, and this is not always true with consumer routers, so I want to asterisk that by saying this is usually true more on enthusiast and then pro level stuff. We can set up multiple networks, or what we refer to as VLAN, a virtual local area network, right? Not physically, we don't have another router. We do this within that same box and say, hey, you know what? We're going to set up this range of IPs as one network. We're going to set up this range of IPs as another one, and how many ever you need. And the beauty about doing that is then you can assign different things in your physical structure to different networks and set up rules about how those different networks can talk to each other.
Yeah. So this is when we get into kind of the equipment side of things, right?
Yep.
What do you want to buy if you were setting up a kind of studio network?
Yep.
I and Robbie and everybody I know are big fans. We've talked about it at length of our friends at Ubiquiti. And what Ubiquiti does is they're an ecosystem of networking products, from what they call their Dream Machine product line, which is basically a small computer that does integrate the router, the switch, and control software to talk to everything. Then they sell switches, they sell other networking stuff like IP cameras and things like that. We won't even go down that road for this episode. But the reason why I bring it up is because When you have all of these different components, it's really nice to be able to manage them from a central dashboard. So
Yep.
let's talk about the VLAN configuration that Robbie mentioned. You could set that up. Let's say you have a work network and a home network. You could very easily set that up on just two separate physical switches and then connect both of those switches to interfaces on a router and have the router configure what can talk between the two switches.
Right.
And then those networks are physically isolated. That's a very simple way to do it. But now you're managing two different switches and one router. Each one, you probably go to its little management page and check its little options and do that. It's a big pain in the butt. When you get a networking product ecosystem, Ubiquiti is the example we're going to use. There are plenty of others.
Yeah, Cisco, whoever. Right? Yeah, sure.
My favorite.
Yep.
You get a central management that talks to all of the components in the same language. And the way that looks with Ubiquiti is, for example, you go to your main configuration dashboard. That's talking to the router. It's talking to all your switches. So all the switches are connected to the router. And I can say, take these 5 ports, put them on the work network.
Yep.
These 5 ports, put them on the home network. Anybody connecting to this wireless network, put on work. Anybody connecting to this wireless network, put on home. And then what happens in that case is anybody that's on the work network can talk directly to anybody else on the work network. Anybody that's on the home network can talk directly to anybody that's on the home network. Or they can talk via the router out to the internet. But if one from the home network or one from the work network wants to talk to its counterpart, it needs to go back to the router and say, hey, okay, I'm on the work network.
Permission to do this.
My address is 10.0.0.1. I want to talk to 192.168.1.1 on the home network. You need to broker that connection. And that's where you have things like firewalls. A firewall is essentially just a piece of software that decides what, when, and where the router can send different communications.
Totally.
So you can say, for example, the way I have it set up is my work network can always reach out and talk to the home network or the internet. The home network cannot talk to the work network with a couple of very specific exceptions to get into, like, oh, I want to get to my management page for my NAS. I let that through the firewall. So that's where this network segmentation can become really, really useful if you have them all kind of in the same ecosystem of products, because you can manage it all from one dashboard.
Agreed. And just from a practical sense, I want people to think about this segmentation and the firewall rules. Firewall rules they sound complicated, but they're really not. They're literally just, think about it as a complete solid brick wall that when you set up a rule, all you're doing is punching a little hole in that wall for that specific use case and nothing else. And the beauty about this, like from a practical use standpoint, is, let's say you have your office. You don't want your clients to be able to access your storage servers, your actual workstations, etc. Sure, you want them to be able to get on the internet and be able to do things that clients do in the room, but they don't need access to all of your proprietary gear or machine, stuff in your machine room. So setting up segmentation like that, to be clear, it requires a little planning, requires a little forethought, and a lot of modern appliance ecosystems, like Joey was talking about, make this pretty nice with like color coding and different flags.
Yeah, and a lot of them have presets for this.
Yeah, exactly. So you can make it up. But that kind of idea about separate networks, creating these virtual LANs, and routing rules is important. And kind of related to that same kind of concept is that once we start configuring, different networks, different VLANs, routing rules, you can take this up another level with security initiatives too. It's because it's semi-related, right? We can start doing things like in those firewalls, we can create specialized parts of firewalls. For example, for security, this is often called like a honeypot, right? Where to the outside world, you're basically saying, hey, if something is intruding on my network, make sure that intruder knows about this IP to go to and try to mess with, because once they're in there, guess what? they're stuck. There's nothing to find. They can't touch anything else on your network. Sure, they can see that it's a network there, but like malware and bad actors are automatically made to go to this little honeypot. Same thing for things like ad blocking or other things. You can even do this based on geographic regions, right? If you're, hey, you know what? I don't want the to continually get things like, hey, if you give me $50, I'll make you the crown prince of wherever. You can block countries, right? Countries have IP blocks, etc. And so you can get pretty granular with the level of security once you kind of understand those same kind of concepts too.
Now, the caveat here, I would say, especially if you're building a dedicated work network, is be very, very, very cautious with what you allow in, because, Robbie said that, you punch a small hole through your firewall. Let's say, for example, in my example, it's I can get to the web management page of my NAS so I can see the dashboard. But as it has been said, no crack in a fortress may be accounted small. So it's not a small hole, and you should think about it. The reason I say that is don't do things, for example, like open up remote desktop with a weak password to something on your work network, because guess what? Now that you've opened that up, something on your less secure network can figure out, oh, I've got a weak password remote desktop. Now that I'm on a desktop on the other network, guess what? I've now got access to everything. I've opened up the entire world. So it's good practice to be very judicious about what you do let into that private work network. And I err on the side of almost zero, to the point of it makes life inconvenient, right? You need to go to a different machine to get to certain things, whereas I can't just dial it up on my phone or on my iPad. The cost of security is often convenience.
Yeah, that's all good stuff, Joey. And just to be clear about that, there's a lot of nuance to those kind of rules. Like, we're not going to dive into things like, opening specific ports based on protocol or those kind of stuff. Like, there is another little bit of level on that, but that's kind of the 50,000 foot view of it. The other thing, I think oftentimes about, and this is kind of a hardware thing and a network thing, like a virtual network thing, is like I have different, how should I say this? Different performance needs for different types of systems, right? So for example, like my iPad or laptop, the regular, network, Wi-Fi or whatever is, fine. Like a 1 gigabit speed is more than enough that I need for my iPad sitting on the couch, right? But I might need for my workstations, I might want a 10 gig per second or a 25 gig or even a 100 gig network connection, right? And so that might mean at the top level with gear, it might mean that I have to get an additional switch or a piece of gear that can operate at whatever speeds that I need to operate on. So for example, in my setup, I have a regular 1 gigabit switch that almost all my house is wired into, but then I have a 10 gigabit switch where things like my NAS and workstations, etc., are plugged in. So I needed a different physical piece of hardware that supported those speeds, but also I have a different network for those kind of things, right? So my work network, for example, is defaults like everywhere it is on all the ports that it's on, that work network's on, all those ports, they're 10 gigabit ports because I'm doing things on that network at 10 gigabit speeds, right? So so when you think about network segmentation, it's not just about who can talk to who. It also is a little bit about the performance needs that you have for those specific devices.
Yeah, and all of the components kind of come together at this point, because let's say you have your work network, it's all 10 gig. All the work machines are talking 10 gig to each other, but when they need to go out to the internet, let's say your internet connection is only 1 gig, that router is going to broker your 10 gig connection through to a 1 gig connection to the internet. Now, the next kind of level of performance segmentation that I want to talk about is what's called, you may have heard of jumbo frames. You may have heard of MTU sizes, things like that.
Yep.
This is where that segmented 10 gig work network really comes into its own, because we need to change the way the individual clients are actually talking. And we do that by changing what's called the MTU. Now, in Ethernet, the MTU is the maximum transmission unit. It is for every packet of data. A packet is it's a chunk of data.
Yep.
The MTU is how big that chunk of data is allowed to be. And the reason there's a limit for this is because networks aren't perfect, right?
Right.
So the default Ethernet standard MTU is 1500 bytes, okay? So when you send things out to the internet or on your local network, it's all broken into 1500 byte chunks. The reason is those are error corrected on each one. And when the receiving end gets it, if it says, hey, the math on this packet doesn't add up, can you send it again? It will send it again. Now, if those packets are huge, guess what? You just brought your whole network to a crawl, because anytime there's any error, you're resending gigantic packets as opposed to resending small packets. This matters a lot for the internet or for Wi-Fi or for crappy consumer devices like IoT stuff that might not be very reliable. This matters much less on dedicated 10 gig, 25 gig, or higher high-end equipment like your Mac Pro, your Mac Studio, your network attached storage, your servers that are all on this work network. So the way to get better performance on that isolated network is to set that MTU to a higher number. Now, the standard that's basically come out over the years is 9,000. So we go from a 1500 byte chunk to a 9,000 byte chunk. This means each one of those packets that gets received, again, they still get error checked and asked to be resent if there's a problem. So we're doing, I guess, 1/5 as less often error checking, and we're doing 1/5 as less often headers and other little metadata associated with the packet. So we're taking the overhead of the network and drastically reducing it and letting it focus on raw throughput. This is great for storage. It's great for video, but again, it doesn't work on the wider internet or with normal consumer devices. So again, we have all of these jumbo frame devices on their own switch. The switch has to be configured for jumbo frames for this to work. Otherwise, the switch is going to say, hey, you just sent me 9,000 bytes. I was only expecting
I don't know what to do with that.
1,500. I don't know what to do with it. So then the question becomes, well, okay, how do these machines get out to the internet with their 9,000 byte packets? That's where the router comes in. The router understands jumbo frames because it's connected to a switch that understands jumbo frames. So when you send your jumbo frame packet to the router says, oh, the MTU on this network is 9,000. The MTU on my internet is 1,500. I'm going to take this packet, split it up into 4 or 5 1,500 wide packets, send those out to the internet. On the way back, it does the opposite. But the point is, you can, by segmenting your network like this, you can focus parts of it on performance by doing things like jumbo frames that would break normal networks that you would need for the internet.
And you said this, but just to reiterate this is not like, oh, if I go to jumbo frames, I'm improving my my browser speed to browse whatever a website. That's not this. This is more about data transmission.
If anything, that can get slower.
Right. This is about data transmission within that LAN, right? So if I'm moving files from one system to another system, I'm playing back something off of a network attached storage. And the important part about this too, as you go, I think that this is a little bit of a mind job for some people too, is that different performance networking requires, as we said, maybe possibly different switches, but also generally is going to require different cabling too, right? So for example, to achieve 10 gig speeds, you probably need to have probably at a minimum Cat5e cables. 6 and 6A would be preferred, right? If you start going into 25 gig and 40 gig and 100 gig, and you actually get out of the world of copper-based cables altogether, and you're going into fiber optic cables, right, with specialized connectors on them, SFPs, which are modules for optical cables, and so on, right? So you do have to match cabling also to performance when it comes to networking. And just like we've talked about before with SDI cables and stuff, like, it's pretty straightforward. It's just generations of stuff. They have some funky names like QSFP plus and non-plus and all sorts of stuff, or 6A. Like, it's not all that confusing. Just go to Wikipedia.
Well, the point is, you don't need to spend the money on the highest power stuff for everything. If you're not,
right, exactly.
You only need to spend it for where you need it.
Yeah. And then the last thing I think we should say, just sort of in this overview episode, is just the role of Wi-Fi, because I think this idea of like, I'm the first one to admit, like, I hate cables. I mean, I just rewired my entire basement down here, and I will never, I hopefully I never have to do it again for a long, long time, right? But I think, in a wired world, wireless is attractive. And wireless, to be fair, has gotten considerably better. I mean, like, I just actually upgraded all my wireless access points, and I'm basically doing the same speed as a wired speed now. But there is some trade-offs. There's interference, there's added latency, etc. So, in a professional environment, I think of Wi-Fi as, okay, well, that's going to be for my IoT type stuff, right? Like, right, that probably doesn't have wires. It's going to be for things like client access, right? But all of my main workstations and whatnot, I am striving to get that stuff wired. Not only is it going to be more consistent in terms of its performance, but it also provides a layer of security, right? Everybody's heard horror stories of somebody getting eavesdropped with an insecure Wi-Fi password or something like that, and next thing you know, somebody's on their network, right? So I tend to keep mission critical stuff off of Wi-Fi networks and on wired networks. But just like anything else, even if you are using Wi-Fi networks, take data security seriously. There are encryption methods, obviously, that are in use on Wi-Fi systems like WPA and WPA2, 3, etc. And also, like, a lot of systems like the Ubiquiti stuff that Joey and I use allow for things like guest portals, right? So we can really limit and lock somebody down when they log onto our Wi-Fi, what they're doing. So I think Wi-Fi has a role. I would just urge that in a post-production environment, depending on Wi-Fi for your main kind of backbone is probably a bad idea, right? For a lot.
Yeah, and I would take it to the next level and say, don't let Wi-Fi anywhere near your work network for any reason, because not only is the security an issue, it's also troubleshooting. It's diagnostic, right? It's variables. We want our work network to be simple, purpose-built, doing exactly what it needs to do, because when there's an issue, if we're troubleshooting a performance problem, having Wi-Fi in the mix makes that troubleshooting much more
like
difficult.
for example, if I do a data transfer from my NAS, let's just say it's 10 gigabyte, I'm getting about 1,000 megabytes a second, a gig a second of playback on that every time I test it and try to transfer something, right? Versus Wi-Fi, okay, well, I'm sitting here 5 feet from the router, I might be getting that speed, but then I take my laptop and I go over to the next room and I'm getting half of that speed, right? So, like,
and here's the other thing, right? Because the Wi-Fi is going to be one interface, your wired is going to be another interface. That the computer is not always going to tell you what interface is being used for what. So let's look at the example of a network attached storage. Let's say you did what I don't recommend, which is you've got your sometimes you're wired, sometimes you're Wi-Fi. You might have multiple paths. Well, the protocols that do file sharing that we use, like SMB for mounting file systems, will say, hey, I've got two paths to get to this.
I'm gonna try to use them both.
I'm going to use both because that'll be faster. Well, if one is Wi-Fi and one is 10 gig, it's going to be really slow because it's always going to be waiting on the Wi-Fi. And you're going to be like, wait, I'm plugged in. Why is this going so slow? You've got a whole new layer that you need to diagnose and troubleshoot. It's just not worth the hassle. Wi-Fi is for Internet of Things toys that don't matter and for your clients' laptops.
Yeah, and I mean, I'm not as hardcore about my hatred of Wi-Fi as you are, but I get the sentiment. So, lot of stuff that we covered here. You might have to listen to this one 2 or 3 times to go back. And again, this is, if some of you out there are listening, we're like, well, that's not totally the full picture. Of course, we skipped over a lot of some of the nuance, some of this stuff to kind of explain the bigger, higher level picture. I will just say one thing in reference to the ecosystem stuff. For years, I piecemealed this stuff together. I'd buy a switch from TP-Link, then I'd buy another switch from Cisco, and then whatever. I cannot advocate enough, and I'm not saying strictly Ubiquiti either. I'm just saying something that an IT infrastructure that is, you often heard this phrase as an appliance, right? Or this ecosystem where, hey, all these things kind of know what they are. They all talk to each other. You often hear this phrase in IT, the single pane of glass, right? I'm going to one place to control everything and have it all talk to each other. That is a awesome thing, right? So every time now I need to do anything, I just go to my Ubiquiti account, log into the router, and I'm like, oh, I'm going to adjust the camera here. Oh, and then I need to change this firewall rule. All in the same place, right? So it's definitely something to think about. If you guys have questions about any things that we talked about in this episode, again, 50,000-foot view of some of this stuff, and we went over a lot of it pretty quickly. Feel free to reach out. You can always head over to the offsetpodcast.com. We'll have some additional show notes there with some links out to some of these things that we're talking about, like some of the routers and switches and whatnot. Also, if you find the show on YouTube or Spotify or Apple Podcasts, be sure to give it a like and subscribe. Every little like and subscribe helps us out in a big way. So we appreciate you guys, our audience, for checking out this show. All right, Joey. Well, I think this was a good one. Fun little concept, and I'm sure we'll get lots of opinions on some of this stuff from our audience. But until the next time, I am Robbie Carmen,
and I'm Joey Deanna. Thanks for listening.